Okay, so yeah, I guess I'll just start, yeah, because it's only 3 minutes and we don't want to go too late, because you got schoolwork as well. So yeah, okay, so welcome y'all to the first workshop session. You know what, I'll just start sharing my screen thing. Yeah, also okay. I am recording this, so it's good, okay. Otherwise, last time I forgot to do it. That was a mess. But okay, yeah. So I'll start sharing my screen. How do I share? Desktop, okay. Can you all see my laptop? Okay. So I'll first start by opening up my notebook. So I'm gonna first launch Anaconda, and once I launch Anaconda, yeah. So like last week I sent you a file which talked about how to install this on your machine, and hopefully you have successfully done that. If not, you can always ask me questions about it. But yeah, so thing is, for this workshop, being able to like open the notebook now isn't like essential. So like mainly like I'll be opening the notebook from my end and like just walking it with the code. So that's why it's not like essential for you to have it open. But after this session, like you'll probably like want to just explore on your own, like the code and stuff. And so knowing like how to open this notebook on your own machine is important. So that's why I'll just show like how it's done. So as I said, I'll first launch Anaconda. Then as you see here, this is what we want, a Jupyter notebook, and I launch that. And boom, it should open some funny things, and then it's going to open up a browser. Okay, now can you see the browser or no? Or is it,
Yes, you can see the browser.
okay, cool. Okay, because Zoom sharing, I don't trust it, so I don't know what it's sharing. But okay, yeah. And so now, like, we see like a bunch of files here and folders. So now, based on where you keep the file, you will navigate to that file. So on my machine, I know where it is. So I'm just gonna like click to all the folders where it is. A huge mess on my laptop, but I know where all the stuff is. Somewhere here, yeah, right here. So okay, and once you're gonna see, I clicked on this file here. So this is the notebook which you'll be using, and as you can see, notebooks will have an extension called IPYNB. So if you see that, then that means that's a notebook. And so I click on it, then it says it's running, and then it pops up, and then it pops up like another window, and this is the notebook. So we have arrived at our final destination. So I'll zoom in a bit. Okay. So just to make sure. So can you see my notebook now or no? It's there?
Yes.
Okay,
Yeah.
cool. Cool, okay. So once again, welcome to the workshop's first session. We will be talking about some very basic topics like, print statements, variables, simple math, encoding, then also a data type, which is a very, very important topic, and some things about lists as well. So this is going to be the first in a series, I believe 4 to 5 sessions. And then each session is going to happen on a Monday and a Friday. So this first one is right now happening on Monday. Next one will be on Friday. And then again, the next two on the next week's Monday and Friday. And after that, so after you like finish these 4 to 5 sessions, we will then transition into like group projects where you'll be paired with like a mentor, and you will apply all these sort of basic skills you learned in coding to like an actual physical context. So like some like small research project basically. And that's basically the entire workshop. And so, okay, so that's like the rough overview if you missed that. And yeah, I think that's all background I need to give. But yeah, okay. So yeah, so without any further ado, let's just, start. And also, yeah, okay. I want this to be like, be a very like interactive thing. So if you have any questions, or if I like explain something in a very poor fashion, or just, miss something, please just call out and say, can you please explain that again? Because thing is like, the thing with coding is that knowing how to code and teaching how to code, these are two very different things. and I have never taught how to code basically. And so this is also like this is also like a new experience for me. And so I might make mistakes. And so this is going to be a team effort walking through this workshop. So I would appreciate your patience and a cooperation. So, okay, so with that said, let's just begin. Okay, are there any questions before I start about something, previous things or installing Anaconda or something?
Are we supposed to follow along with our own notebook open, or is this just something that we watch?
Yes, the thing is, I think it's, yes, the thing is, yes, it's over Zoom and it's kind of hard to like guess, watch and code at the same time. So I think it might be best to like just watch and you can then follow, like do, because thing is this, this like is a pretty self-explanatory like file. And so you can like always go back and like read it and things will be hopefully clear. So I think it's best to like watch, and if you have, questions you can ask, or like, yeah. So hopefully that makes sense. But yeah, teaching how to code like over Zoom is honestly the worst thing to teach how to code. We'll see, but yeah, hopefully that answers your question. So yeah, point being is that, yeah, just watching is, I think, the best way. So okay, if I also I can't see the chat. It's kind of hard for me to see it. So Will, I would appreciate if you could like watch the chat. Yeah, thank you. So yeah, okay. So by saying that, let's begin. So as I said, first topic, print statements. They're my favorite, to be honest. So print statements, they're very simple. They just print, what it gives you. So for instance, I want to print the word hello. I just do print and then a bracket, and then inside the bracket, I just I type what I want it to print. And so as you can see, you know what, okay. I'll first actually briefly talk about the Jupyter Notebook interface. I think that'll be useful. So, okay, this is how a Jupyter Notebook looks. Each of these blocks is called a cell, and you can like type code in each cell. You can type some more code, and then you can run the cell by clicking this run button here. And as you can see, like this makes no sense because this like is not code. And so I was going to say that, there's an issue. So this is like basically how Jupyter Notebooks work. They're very nice to use because they give you the instantaneous output of your code, which is like very nice when you're trying to learn how to code. And so that's why we are using this format. So each of these cells, you basically write code, and one can also like add more cells. So for instance, this plus sign here, if you click a plus sign, like it's going to add more cells. And if you want to cut, you can just cut cells. So yeah, this is basically how Jupyter Notebook works. And then once you're done, you can always like, save your file, save as, or just, just save by pressing that. And yeah, so okay, so I think that's like just a quick brief view. Okay, so now, sorry for the brief point on that, but okay. So let's get back to print statements. So print statements, as I said, very simple stuff. It just prints what you give it to print. So as you can see here, I just ask it to print the number 1, it prints 1. If I say to print Batman, I'm Batman, then, it prints that. If it prints hello, it prints hello. So it's, it's quite simple. Now, but the thing is, it's important to realize that in coding is that one should always have like the format the same. And so as you can see, in every print statement, the thing which you want to print is between 2 brackets. And so having these 2 brackets is very important. So for instance, if you missed a bracket and then you try to run this, what you see is that it gives you an error. It says unexpected while parsing. So what this issue basically means is that it says that this format is not recognized by the code. And I can fix this by just putting a bracket. And see, it works. Nice. And same for this, is that for the code to like realize that it's trying to print something, having that fixed format is crucial. And so having this, as I can fix this again by putting brackets, it's going to work again. So main point is that if you want to print something, it should always be between two brackets. And yeah, okay. That's basically like at this stage what you need to know about print statements. Now, if let's just move on to the next thing. Yeah, so like I'll be talking about like all of this more like, as they like appear, but this is just like a brief, like, like what a print statement actually does and what it is. Okay, so now let's talk about variables. Now, the thing is, part of like any coding language, the concept of variables is very important. It's just like mathematics. Like they simply function as like storage of, they simply store information. So like, in math, for instance, we have this equation x plus 3 is equal to 5. This x is essentially acting as like a storage for the value 2. And that's basically the exact same thing in coding as well. So for instance, like I can define a new quantity, let's say x subscript 1, and I can make it like equal to 2. So this is like how like I define a variable in Python. And why does one want to do this? So first of all, here's how you do it. So like, you just call a name. It's that name's up to you. It could be x1, it could be x2, it could be like, whatever the name you want it to be. And then you assign it a value by putting equal mark and then what that value is. And again, it's the thing is, yeah, so now what this does is that these numbers are now stored in these quantities called as variables. And now why this is useful is that now as these values are stored, one can access these values at like any point in the future. So for instance, if I run this code, what this does is that it stores these values now in these x1, x2, and y. And now if I print these values, and as a reminder, I talked about print like briefly like a second ago, if you print the values of these variables, we should be able to recover what they were assigned. So as you can see here, if I just print this x1 statement, so x1, so as you can see, we above assigned here x1 the value of 2, and so printing x1 gives us 2, which makes sense because x1 was assigned this value of 2. Same for the other thing like x2, we assigned it the value of 3, and it's going to print 3, and same for y. So these things are useful because we can like assign these variables values, and then we can use them in the future later without always typing number 2 in our entire code. And so these are just like sort of like a nice cheat, one could say, just like help simplify things. So hopefully that like kind of explains why they're used. And thing is, with variables is that we can assign them values, but we can also assign them values through other variables as well. So for instance, up here, I said that x1 is equal to 2 and x2 is equal to 3. Now x1 plus x2 is, we know math, it's 5. But what I could also do is I can assign the value of x1 plus x2 into a new variable. Let's call it addition because it makes sense. And now this variable addition is going to store this new, this variable addition is going to store the value of x1 plus x2, which is 5. And so as you can see, once you print the value, it gives you 5. So it all seems to make sense. Yeah. And the thing is, okay, now the thing is for using variables to like, say calculate the value of 2 plus 3 is equal to, using variables to calculate the value of 2 plus 3 isn't like the most efficient way to do it. Like, well, like all we could have done is just like, just print 2 plus 3 and that's going to give us 5. But then here's just like a simple example. So maybe this is not the best example to like show how useful these are, but point being is that for like more long and complicated codes, using variables is always the best way to go. And also, just so you can make things clear, x1 plus x2, as I said earlier, is 3 plus 2, which gives you 5. And also you can just print this new variable which was assigned the value of x1 plus x2, or you could just always just print what is the value of these two, of the sum of these two variables. And okay, so hopefully that sort of explains the basic functionality of variables. Another sort of slightly more non-intuitive feature is that one can reassign the value of variable. So for instance, if I first assign, okay, let's call var1 as our variable, and let's assign it the value of 1. But for some reason, I don't want it to be 1 anymore, and let's reassign it to value 4. So now what this basically does is that so if I just, get rid of this, and so now we have that, var1 is equal to 1, and so if we print it, it's going to give us the value 1, correct? But I can always reassign the value at like a later part. So what happens here is that it first sets the value 1 is equal to var1. Then it goes to the next line. And then in the next line, it sees, oh, okay, it's being changed to value 4. And so what this part does is that it overwrites the previous part. And then we see that if we run this part again, we get that var1 is no longer equal to 1, but now it's 4. And so reassigning variables is also a functionality of these things. And just like another concrete example of this is that, for instance, let's start with var2 equal 3. And I print var2. Correct. Now let's just call var2 is equal to var2 plus 1. And if you print that, what's going to happen? We should expect that the value should be 4. So now, okay, thing is, we see two things here. It's because we're printing two statements. So this first one is being printed on the first line, 3, and this second one is being printed in the second line. So that's why we first have 3, because once it was running the second line, var2 had a value of 3. But then we reassigned it to this original value plus 1. And so in this line, what's happening instead is that when it's running, it's going to run on its previous value. So as it's equal to 3, it's going to be 3 plus 1 is equal to 4. And hence, we reassigned the value to be the sum of its previous value plus 1. And it's going to print it as a 4, which makes sense. Then I can again do the same thing again if I just reassign it. And if I do plus 6, for instance, one should expect that it should be 10 because its previous value was 4 and now we are adding 6 to it. So that's going to give us 10. And correct, that makes sense. So cool. Okay, so hopefully I explained in a very clear manner what variables are. If there's any confusion or if I just made no sense, please let me know, because thing is with coding is that the more simple the concept is, the more hard it could get to explain it, because it's I guess that's just the way coding works. And so yeah, if there are any questions about this, please ask me now, or if I'm going too slow, which could also be the case, please tell me that as well. So are there any comments or questions at this stage? I think I'm going a bit slow. I think I can increase my pace a bit.
We have one question, Raj.
Oh, okay.
From Annie.
Okay.
She asks, do you need to declare types for variables?
So in Python, no. It automatically recognizes what kind it is. So okay, so I'll talk about that more soon. But yeah, the answer is no. That it senses the kind it is. So these types of, so by types I mean I think you're referring to a data types, like if it's a decimal number like a float, or if it's an integer or stuff like that. So I'll be talking about that very soon. So hopefully that should answer your question then. But yeah. Okay, so if there are no comments, I'll move on. Okay, so we used, okay, so just coding, like any part of code is being able to do simple math, and in Python it's fairly intuitive how to do math. So if you want to do addition, it's just a plus symbol, like simple math. If it's a subtraction, it's just a minus symbol. If it's multiplication, it's an asterisk. If it's a division, I think it's just a backwards slash. I think it's called, no, sorry, it's a forward slash, yeah. And if it's an exponent, it's just a double exponent. So if I run this cell, and if I just do print the value of what the value of the exponent variable is, that gives me 16, which makes sense because 4 to the power 2 is 16. If I print a division, boom, that should give me 1.5, which makes sense because 3 over 2 is 1.5. So, okay, this is basically sort of like the main the main sort of math functionality of coding. It's just like the simple plus minus asterisk stuff. Okay, now, let's do a quick example. So, okay, let's say we have 3 friends, Alice, Bob, and Chris. They each caught like 6, 2, and 5 fish respectively. Our goal is to find what is the average number of fish caught. So using what we know by now, we can actually do this very easily. So let's say Alice is a new variable, and let's assign it the value of 6, which makes sense because Alice caught 6 fish. So like also naming your variables is very important, because at the end, like if you come back and see, okay, what was Alice? Like, was it Bob's fish? So like, point is that having like a naming scheme that is fairly easy and intuitive to know is very important when it comes to naming variables. So let's call Bob 2 fish, and then Chris, let's call Chris as 5 fish. Yeah, because you got 5 fish. Okay, so now we have this. Now, when you want to calculate the average number of fish, it's like basically going to be the total number of fish caught upon the number of people who were catching the fish. And so if you run this, so now what has happened is that these variables have been assigned these 3 values. And now to calculate average based on what we learned in this simple like math stuff over here, we first calculate the sum of all the fish caught. So it's going to be Alice plus Bob plus Chris. That gives me the sum. And this entire sum is going to be divided by the number of people we have, which is 3. So the thing is also math and coding, it follows the simple like BODMAS thing rule. Like, you know, first it's going to like solve all the things inside the bracket, and then it's going to like evolve like that, like first brackets, then something like whatever that a full form stands for, BODMAS. But yeah, so first it's going to find the value of the sum, and then upon 3, that should give us the average, and it's 4.33. So awesome. Okay, so now we know the average. So like now we know the average number of fish caught. Perfect. Okay, so hopefully this makes things a bit more clear about maths and assigning variables. Okay, so now let's go on to the most important topic, data types. So when we're coding, we're basically like looking at data and like, you know, trying to like simplify it, or trying to find patterns. But data always has its own shapes and forms, so they all won't have the exact same format or like the same type. And so in coding, one can sort of like split all the different kinds of data into 7 kinds basically. And like I think these are like the main ones, but we'll be simply focusing on the first 5, and these 6 and 7, these are like important, I would say, but I think in interest of time, if it's getting close to 7, I might skip a 6 and like, I might skip the last 2, but yeah, let's see. Okay. So first, integers. Fairly obvious, as the name says, is just a data that is an integer format. So for instance, x is a variable. We assign it the value of 2. Now, as we know, 2 is an integer number. And so to find what data type that variable is storing, all I have to do is, it's a fairly obvious command, is just do type. So this is what I do if I want to know what type of what type of variable that x variable is, or what type of data that variable x is storing. So as x is storing an integer number of 2, if I print out, again, these print statements that, you know, is that these print statements, they always print what is in between the 2 brackets. This print statement is printing the type of the variable x. And so as you can see, we expect it to be an integer, and that's exactly what we see. So it says class integer with this class int, which basically stands for that this x is storing an integer value. Okay, hopefully that makes sense. Same for this example at the bottom, is that x is equal to -19. which is also an integer. And if you see, it prints the type, and it is indeed an integer. Okay, so hopefully the concept of integers was clear, and how to use the type command. So okay, also as a quick recap, this type command just tells us what data type the variable is storing. Now moving on from integers, the next sort of like natural thing to think of is like, what about a decimal numbers like 3.2 or like 1.0001? And those are basically called floats. Now, floats is a weird name, I would say. Like for me, I was like, why call it floats? But then I guess over time, it just sort of like just ingrained stuff. Like it sort of like just stays in your brain. So I guess so floats are basically short for floating point number. So hopefully like this floating point kind of like hints towards, it's sort of linked to a decimal point. And so, yeah. And so floats are basically numbers that are like not integers, like they have a decimal point. So as you can see here, if I assign X the value of 3.14, it's going to print, and if I print its type, it's going to print a float. So bingo. Also same for 2.0. So it might be, it might be a bit like unclear that why it's printing for X equal 2.0 as a float. But the thing is, 2 and 2.0, though they are the same, they are stored as different kinds because of this a decimal point here. And so keeping that in mind is like an important, yeah. So it is a second important point to keep in mind. But yeah. So yes, like, yes, for instance, here as you can see, X is equal to 2 and Y is equal to 2.0. They both are the same value, but they are different types. So, just something to keep in mind. Another kind of float is sort of like scientific notation, basically, is that if you want to represent like extremely large numbers in your variables, you don't want to be typing like 31 zeros. So what you do is basically you use like this thing called E, which basically tells like what number you're raising 10 to. And so for instance, if I do 1E3, that's basically 1 times 10 to the power 3, which is 1,000. And so 10 is basically going to be 1,000. The sun's mass is given by 1.989 times 10 to the power 31 kilograms. And so if you don't want to be typing 31 zeros, this is the way you want to store that the sun's mass in a variable. Same for the mass of a proton, is that it's given by 1.672 times 10 to the minus 27. And so you can see using E is like a fairly effective way to store large or very small numbers. And as we're talking about, coding in physics, for instance, this is sort of very important because physics deals with numbers on all scales. And so just keeping this in mind is going to be important. So, okay, we talked about floats and integers. So, okay, hopefully that's clear. If there aren't any questions, I'll just move on ahead. So strings. So strings also, okay, so we talked about numbers now. Now, the thing is, numbers aren't the only kind of data. One can also store like, text, like words, letters and whatnot. And that's where strings come in a picture. Now, again, strings, it might be kind of like not obvious why they're called strings. I also don't know why they're called strings, I think. But yeah, they're just called strings. The thing is, with strings is that they're very flexible. Is that like anything between two, anything between two quotation marks is called a string. And so, for instance, this word hello, if I write it between two quotes, just quote here, and I have a string now, simple. So if I were to just call x1 as hello, that would give me an error, I believe, because it says hello is not defined. So because the Python has no idea what hello is, like it does not speak English. And so that's why to tell the code that we're storing some kind of text or some sort of like it's like thing that isn't like coding, that's how we can like store two strings, for instance. So hello. The thing with strings is that they're very flexible. So they aren't like, just words or like letters. They virtually could be like anything, as long as it's between two quotes. And so as you can see here, if I run this, I see that all these x1 to x6 variables, they all are strings. As you can see, class str. Str stands for string, basically. And so as you can see, even like, storing the value of 1, 2, not value, but like just storing 1, 2, 3, 4 between quotes, though it may seem like, though it may seem like it's a number, it actually classifies it as a string because it's between two quotes, basically. Same for like, just like basically like any random thing between quotes is going to count as a string. Also, even space marks are counted as a string. So yeah, virtually like anything inside two quotes is going to count as a string. Okay, so so that's basically strings. Now we talked about using sort of like math encoding and like how we can like do simple mathematical computations like addition. Well, we can also combine strings as well, like basically texts. And the way we do it is just the same way we do basic numbers, is that we have a string 1 which stores which is a variable that stores the value c, basically the string, and string 2 is storing the value of ya. And then if I add these two strings, these aren't like add in like the mathematical sense. It's more like, you're combining these two strings, and you get that it's basically gonna sort of like join these two strings into like a single sort of word or text. And it makes sense. So it takes c plus ya, and it gives you cia, which makes sense. Good. But thing is, now, if I want to have a space in between, so for instance, if the way I write cia is like, c is one word and ya is another word, then sort of like this makes no sense. And so what you would do maybe is just like add like a space mark here. And like, as I mentioned earlier, strings are basically very flexible. Like anything between two quotes is going to count as a string. And so if you put a space mark here, it's going to sense that space mark, and so when it adds, it's already going to have this space mark in between. And yeah, and so yeah, sorry, my dad came. So yeah, c plus yeah, so like as you can see, it's going to have this space mark right here in between. So now this seems more like English. So yeah, okay. That's about strings. Okay, hopefully that wasn't too confusing. Next up is this thing called as Booleans. They basically exist in two states mainly, true and false. It's pretty simple. I can just assign x to be equal to true, y is equal to false, and it's gonna, if I print its type, it's gonna be, bool. Thing is, we won't be talking about this much right now because these are very useful things in sort of like in things called as conditional statements. So we'll be talking more about this Friday. But yeah, these are extremely useful things. One thing to just note now is that the first letter should always be a capital. So if I do small t, it's going to give like true is not defined. Same for F. So just what to remember now is that both T and F should be capital. Okay, that's all. That's all I'm gonna talk about now. Now we come to the very important topic of lists. These are, I think, my favorite kind of a data type. So list, as the name suggests, is fairly simple, just a list of things. And these things could be anything. It could be numbers, it could be strings, true, false values, integers, like virtually anything. So as you can see, and the way we define a list is, we have a variable that's going to store this list, and then we equate it to the actual list. And this actual list is going to be stored in between two square brackets, as you can see here, bracket square 1, bracket square 2. And each item inside the list is going to be separated by a comma. So the first element in the list is number 1. Then the second is number 2. Third is number 3, and the fourth element is a string called Batman, and the fifth element is again a string called 1, 2, 3, and the sixth element is actually a list. So with lists is that we can also store lists inside of lists. So lists are like just very flexible objects. Like we can store like virtually like anything we want to store. And the seventh element is a Boolean, which we talked earlier, is true here. And if we print the type of this variable list1, like what sort of data type it's storing, we get that it's a list, which makes sense because we just, yeah. So, okay, so this is how you just, define a list. Now, the thing is, this list is actually like a big mess. Like it has like this sort of like random sort of items in it. So in real context, we probably won't ever like use a list like this. So again, now let's just consider like a more useful list, for instance. So for instance, this list2, it could be a list of the first 5 squares, like 1 square, 2 square, 3 square, and we're just storing these in a list. That's, more like reasonable. I say a more like practical way to look at lists. And so now, okay, we talked about a list, like how to define a list. Now I'll briefly talk about indexing, and I'll come back to this at the very end again, but I'll just mention it here. So with lists, like I said, each element is separated by a comma, and as you have, so the thing is now when you make a list on your own, like, say for instance, all the things I have to do in today, usually it goes like, number 1, this is the first task. Number 2, this is a second task, and so on. And so when you make a list, you're sort of like labeling each item in the list by like a number, like the first position, second position, and so on. That's the exact same thing in lists here as well. And this sort of thing is called indexing, where each element in the list is being indexed, so it's being indexed by a value. However, there is a sort of complicated thing, or like sort of like non-intuitive feature of this indexing here, is that if I were to make a list on my own, like on a piece of paper, my first item would most likely be number 1, and then I'll go to 2 and 3 and so on. But in coding in here, the first element of a list actually has an index number of 0. Haha. Yeah. So it's like, I think like, so personally for me, like this was kind of like hard to like, just comprehend, like why would it be 0? And like, I always forget why it's 0, but this is something which you'll have to remember for sure till the end, till the very end. And so always remember first element, index number 0. One way you can remember this is that, for instance, if you take a look at the workshop series, for like this workshop series, our first workshop last week, which was not like a live session, it was labeled workshop number 0, and this is workshop number 1. So if that helps, that's one way to like think about this like non-intuitive indexing and coding. So yeah, okay. Now just like a practical example of it. So okay, so here I said, okay, list 2 is going to be 1, 4, 9, 16, 25. Now, if I want to access the first element, what do? I just print the list. So I type the variable which stores the list, and then I do again a square bracket, and then I type inside the index number of the element. Whoa, my bad. I type the index element of the item which I want to print. So for instance, I want to print the first element, so I'm gonna type index 0, 0 here, which basically tells the index, and that's gonna print 1. Now, if I want to print the second element, remember, it's gonna be the index number 1, and it's gonna print the value 4, which makes sense. Index number 2, which is the third element, it's gonna print number 9. So you can see 1, 2, 3, 1, 2, 3. Okay, so that's basically like indexing. And for instance, if I try to print the fifth index. Thing is, it says list index of the range, which makes sense because thing is there are only 5 elements, and the last element has an index number 4. Why? 0, 1, 2, 3, 4. So there is no index number 5, and so this issue makes sense. So one has to be cognizant of what index number we're actually typing. Like it has to make sense because this list, if it does not have that index, then it's not going to print that. Okay, so that was about lists. Hopefully that was clear. If there are any questions, you can ask now, or I can continue ahead. Okay, I think in interest of time, we are already 6:43. I think I might. Okay, you know what? Okay, like I'll just. I think it's best. I'll for now just skip dictionaries and tuples, and I'll come to this at the very end, so that I first talk about the very important stuff, and then I'll talk about this. Yeah, so like, not that these aren't useful, is that I personally in research, for instance, don't use this all the time, and so it's fine if I skip this for now. But you know what? I will come to this at the end, so don't worry about that. Okay. So a quick recap again. Print statements. So it's just going to print the value of the variable or string I give it. So for instance, if I assign 5 to a variable number, if I assign phi to a variable number and I print it, it's going to print 5. Same with the string. If I assign the string of earth, again in between 2 quotes, to the variable text, is going to print text. So that's the print statement. Again, we have these numbers like integers. So I misspelled integers. That's okay. Floats in scientific notation. So floats are basically points that have a decimal point, and scientific notation basically is given by an e, where e2 or like e minus 11, it tells you what power you're raising 10 to. So 1e2 is going to be basically 1 times 10 to the power 2, which is 100. And the second one is basically 2.5 times 10 to the power minus 11. So okay, that's scientific. That's scientific notation. Then strings are just again very flexible objects. Just like anything in between 2 quotes it counts the string. And then lists, again, as I said, is lists are just just a list of values. Like those could be numbers, or they could be letters, strings, lists again. So yeah, they're just a list of items, and always lists are going to be defined as between 2 square brackets, and each element is separated by a comma. So those are lists. Now let's talk about some more important features of lists. So I mentioned like indexing earlier. So here's like a quick recap, I guess. So let's consider this instance. So 10, 20, 30, 35, 50. And if I print, say I want to print the first element of the list, what do I do? Okay, I think it's best if I just start. Okay, so this is our list, and we want to print, say, the value of the first element. So I'm going to first type the actual, I'm going to first type the variable that stores the list. Then I'm going to put in the index of the element I want. So here we want the first element, which is again, which is the 0th index. Very important, not the first index, the 0th index. And if I print this, it's going to give me 10. Awesome, that works. If I want to find the second element, it's going to be given by 20. Good, that makes sense. Now, another sort of thing is, if you don't know the last, so say you want to print the last element, but you aren't sure that, you know, how many like elements there are. So for instance, you might guess, are there 10 elements? No, it says it's out of range. Probably 7. So it's probably 7. That's still out of range. So the thing is, if you don't know how many things are inside your list, but you want the last element, the easiest way to do it is just do -1. Oh, sorry, -1. And so this -1, this is going to print the last element. And I'll actually stop sharing here for a quick moment, and I'll share something else just to sort of explain this thing clearly. Hopefully I'm not going too slow. I don't know. It's my first time teaching coding, so I might be going too slow. So I will like send out a form after this for some feedback, which would be very helpful, because I think that's the best way to know what is happening. Okay. Well, thank you for your words of encouragement. Okay, so I'm going to share my screen here. So here, okay. Here's like a rough thing I sketched up on like a piece of paper. So this is the list we talked about, this 10, 20, 30, 35, 50. And these numbers on the top and the bottom, they're basically the index values. And so as I said, I said earlier is that the first element is indexed by the number 0. And so you can see 0 is the first element, 1 is the second element, 2 is the third element, and so on. And if you want the last element, you do -1. So you see -1 is the last element, -2 is the second last element, and so on. And so this is like basically like all about indexing, like how a list is sort of like indexed, if that's a word. But okay, so I'll start sharing this. Hopefully did this explained things more clearly. Okay, now I'll go back to the notebook. Okay, so you know, as earlier, this -1 is going to print the last element, -2 is going to print the second last element, and so yeah, perfect. Now, so here we were focusing on sort of like extracting like a single value from the entire list. But what if we want like a range of values, like, you know, or I would say a slice. And so this is where we sort of like learn how to slice lists. So okay, so in slicing, what we do is we specify the first index and the last index, and based on that, it's going to extract the part of the list that falls inside those two index values. So for instance, let's look at the slice 0, 2. Now for slice, the way it works is that we put a semicolon in the middle, and that basically tells that we're trying to extract a slice of this list. And so what this first number means is on the left-hand side of the semicolon is the starting element of the slice. So where we want to start the slice from. And the number on the right-hand side of the semicolon tells us where we want to end the slice. And so we are putting in, so what this means is that we start slicing at the first element, and we end at, we start the slice at the element labeled 0, which is the first element, and we end it at the element labeled 2, which is the first element. Sorry, which is the second element. No, wait. You see, it's very like, you know, confusing. So I made something. It's okay. I sort of made a mistake here. So this is okay. 0, first element. Okay. And index 0, first element. Index 2 is third element. Okay, it's not the second element, it's the third element. And I too sometimes mess up with this, but okay, yeah. And what this is that we want to end the slice at the third element. So that's why it prints out the first element, the second, and then it stops, because we want to end it at the third element. And so that's how you slice the list. So for instance, if I make this, for instance, 3, what it's going to do is it's going to print the first element, the second element, the third element, and then it stops, because we stop at the element which is indexed third, which is the fourth element. So, yeah. So index 3, fourth element. But okay, hopefully this was clear. So, okay. I think I talked about this too much. Okay, now we can also modify lists now. So for instance, list, okay, so we had this list here, and if I print what this value was, what the value of the fourth element is, it's basically 35. But then I can reassign this, as we talked about, we can always reassign the value of variable to 40, for instance. And so now what this does is that it's going to change the 35 to a 40. If I print that again, it's giving me 10, 20, 30, 40, 50 instead of 10, 20, 30, 35, 50. So we now can change the value of a list. So that's very useful. We can also append, which we can add more stuff to a list as well, which is always useful because, lists, sometimes we miss a few items and we want to add stuff to it. So we can add to our current list another number 60. And if I add that, and if I print the list again, it gives me the number 60 at the end. So, very, very useful thing with lists. We can always add it at the end. Now, a few properties of the list. So, now these properties are mainly useful like only when your list has numbers. If there are strings, these sort of aren't that useful. I mean, like especially I'm talking about the sum and like the max. And this length feature is always going to be useful. But yeah, okay. So sum, it says sum of all that. Well, sum of all the elements in the list. Length is just how many things you have in the list. Max is the max value of list, and so on. So as you can see, if I print the max value of my list, so how does max work is I first type this function, and then okay, the way I do it is I first type the function max, then a bracket. So all functions always have these bracket things. So and then inside the bracket is where you type the list that you want. So our list here is called list example, and then I can print this value, and then boom, it gives me 60. And same for the minimum or sum or length. So if I just run all of these, it gives me a lot of useful information. Is that the max is 60 and the min is 10, sum is 210. That's good to know. And the length is at 6. So there are six different objects inside this list. So that is useful. Okay. Okay, so that one more brief thing about a list, and then I'll go to some more concrete examples. We're almost out of time, so just bear with me for 5-ish more minutes. But okay, so the range function is is that if I want to have a list of all the numbers between say 1 and 10, this is what I do is I just type range, and then I type my first number, my second number, and then then I do list, and then it's going to basically print all the numbers starting from 1 and ends at 10. So we have numbers from 1 to 9. So the thing is, okay, crucial to know is that this 10, it's not going to count the 10. It's just going to end there. So it's going to only print up till 9. So, okay, I can always do 100, and it's going to print, whoa, all these numbers from 1 to 99. So yeah. So it's a very useful function. We will be talking about this more in the future, but yeah, for now that's enough. Okay, so now we're almost there. We're almost at the end. We'll now just talk about some concrete examples. So we talked about some lists and how to change lists, about kinds of variables and the values and the different values we can assign them. And so sort of using using all these concepts, we can now try to look at a few examples. So for instance, okay, say we want to calculate the area of a circle. So we'll need two things, which is the value of pi, which I've assigned here, variable pi is equal to 3.14. That's how we assign variables. Pi is equal to some number, which we want to be equal to 3.14. And then we have a thing called radius. Let's say we want 5 units. So now we can always have area is going to be our new variable, and using these two previously defined variables, we're going to define a new variable called as area, which is basically is going to be the area of the circle. And so, as we learned in high school math, is that area is going to be given by pi. So we first type pi, then times, as I said earlier, math. So in coding here, when you want to talk about multiplication, you use a single asterisk. So that's going to be the value of pi times radius and square. So as you can see, this two asterisks, which means exponentiation. So we're raising radius to the power 2. So we're taking the square of it. And so this should give us the value of the area of the circle. And so we print this, we get the area 78.5, which is correct, I think. But it's correct. And so we can always write sort of more, it's just do more complicated stuff and just find maybe say for instance the surface area of some hypercube or whatnot. But it all just stems from these very basic things like assigning variables, doing simple mathematical operations and stuff like that. So hopefully this sort of was a simple example. We can also talk about another example here. So here I sort of use a new notion of importing a package. Now I will be talking about this more on Friday. So for now all you have to know is by import I mean I'm trying to import some external package or bundle that has these extra special functions that I want to use. And so for instance, I want to use the function square root, but thing is native Python I don't think it has the function square inbuilt. And so that's why we import a package called math, and then using the functions of math, we can then use this square root functionality of this package. And so you can see if I do print math.square root 4, it's going to print the square root of 4 and give the value of 2. So correct. Now let's talk about how we can find the distance between these 2 points. So now, again, so we have these 2 points, x1, y1, x2, y2. We define their coordinate positions by assigning them to different variables. And again, these variables make sense. These x1, y1 corresponds to the first point, x2, y2 corresponds to the second point, and so on. And now let's define a new variable called distance, which is going to be the distance between these 2 points. We say, we start by it's equal to something. Now, the distance is always given by, x1 minus x2, whole thing square, bracket is important here because it's not x1 minus x2 squared, it's x1 minus x2 whole square. And then again with y1 as well. And this again whole thing square. And now we want this entire thing to be under the square root because that's how distance is defined. And so as we did here, we first do math.sqrt, which basically means it's going to take the square root of the value inside the function, and then we put it inside brackets. Now, one important thing in coding is always to know is that your brackets are important. So keep a track of which brackets are there and which are using. So for instance, this bracket here corresponds to this bracket, this corresponds to this, and this corresponds to this. So always your brackets should be appearing in pairs. And so if they aren't in pairs, then something's wrong. And so, and I think I saw a question. So, well, chat go. Whoops, I can. Is the math part of square always the name of the package? So I imported basically. I'm calling Python. Okay, now we're gonna import something, and then here is where I type the name of the package. So I could also import other packages called for instance numpy, import scipy. So we will be talking about these other kinds more. So probably this Friday or next Monday. But so this math always means the name, the package one's trying to import. So back to our distance. So now we had x1 minus x2, y minus y2 whole square, and this whole thing under the square root, and that's going to be the distance. And if you print this distance, boom, that gives a distance between the 2 points. So that's fairly easy. Was one last example, and then I think we should stop here because we're already slightly over time. But yeah, so this entire notebook is with you guys, and so you can always go back and just read this more closely and try stuff on your own, because time is always going to be an issue. But yeah, okay. Let's talk about this last example, and then we should be good to go. Okay, so now say you're a teacher of a class, and you have I don't know, a bunch of students in your class, and they all give a test, and your goal is to find the average score in the class. Well, not the standard deviation. I don't mean to put that. Not now. Okay. Okay. So now here is a list of all the students and their scores. So not and. So yeah. So it's each student and their score. So so as you can see, it's a pretty big list. And trying to find the average using a calculator is going to be kind of tedious because it's a big amount of numbers. And so that's why we use coding, and especially lists here. So we define a list called scores, which stores all the values of these variables. So it's going to, we define a variable scores, which is going to store the list of all the values of the scores. Hopefully I didn't mess up what I said, but okay, yeah. And so to find the average, all we have to do is, we find the total sum of scores upon the total number of students. And as we mentioned earlier, is that lists have these special features or functions. Called sum and length. These sort of give us the sum of all the things inside the list, and length gives us the number of items in the list. And so that's, so to find the average, we do the total sum upon the entire length. So we define a new variable called average, which is basically the entire sum of the list upon the length of the list. And if you print average, that's going to give us the average score. And if you run that gives us 59.11, which is the average of the class, which is, it's good. And it was fairly quick and easy, so that's awesome. But okay, now you just realized that you forgot to create a test, and that score was a 97. Now one way you could now add or update your analysis is that just append, as I said earlier, append adds a new item to the list. So you append the number 97 to your list scores, which is defined up here, and that's going to add this new score to it. And then you just redo the entire thing again. And here we have a new variable called new average, and then that's going to give you the average, and you print it, and it gives you a new average. Is correct. So okay, that's it. Yeah, and then you can print this result in a fancy way. So for instance, print statement, I said earlier, is as print the average score the class is, and then what I'm doing here is so this str, if you remember, is basically string. And so if you do this thing here, okay, so new average here. Oh, okay, 1 second. New average here, if you print the type of new average, it's a float. And the thing is, one float basically means a number. And the thing is, one cannot add a string and a float because they're not the same. And so to write this entire thing in a single statement, you'll have to first convert this float to a string. And that's exactly what's happening here, is that this str is going to bracket the float, and so this converts it to a string, and then we add it, and then this prints this, and then ta-da, that's it. Okay, so I think I'm going to stop here because I'm 7 minutes above time, which is late. So okay, I'm going to stop here. So if you have any questions or comments or anything, feel free to ask me now. This notebook is with you guys, and so you should be able to go back and just redo all this stuff. And as always, I did skip over some stuff because I think I went a bit slow than I wanted to, and so but yeah, okay, if there are any questions, you can always email me and ask me about it if something wasn't clear, and I'll be more than happy to talk about it more. But yeah, I'll stop sharing here. If there aren't any questions.
I have a quick question.
Oh yeah, sure.
if so you can't add a string and a float, but can you add an integer and a float?
Yeah. Okay. You know what? Okay, well, let's do that. You know what? That's one thing about coding is that we can always, try it. It's not like some theoretical physics where it's kind of hard to test our theory. Here we can test it very easily. Okay, so as you said, 4 plus 4 works, we know. Now let's try 4 plus 3.14. That does work as well. That makes sense.
Yeah.
It works. But if I do now say a string, hello, or I don't know, hello, Jello, okay, Jello, plus 3, this doesn't work because this is like a piece of text and this is like a number. And so it makes no sense to add these. But if I make this a string, it's going to add them into a single quantity.
I see.
So yeah, hopefully that answered your question.
Yeah.
As another thing, if you ever have an operation that involves both an integer and a float, like Baraj just did, it's going to convert your final answer to a float no matter what. So if you divide numbers or multiply numbers, one of which isn't an integer, you're always going to end up with the float.
So here, yeah, correct. So here, yeah, absolutely right. So 3 times 4 is 12, which is still an integer. But if I do 3 times, I don't know what to do, 2.5, it's going to give me 7.5, which is, makes sense because the value is going to be a non-integer number. But yeah, that's right. Are there any more questions? Was the pace too slow or too fast, or was there like any feedback on that, or it's okay?
It was fine. I think you could go just a little faster, but it was good.
Okay, cool. Thanks for the feedback. Yeah, much appreciated. Okay. Okay. So yeah, I think yeah. So if there aren't any questions, we can call it a day here, and we'll again meet on Friday, which I'll send an email about when Friday comes. But yeah. Okay. Well, have a good day, everybody. See ya.